Hi, my name is Corey from FTC Team 9779, the PIEaters, and today I have a FTC Programming Basics video. First, I thought I'd explain why I'm making this video. It's basically a beginner's guide to get your hardware named and ready for coding, introduce some basics of Java concepts like classes and methods and variables, and familiarize you with the concepts of opModes and how you can register them and use them to program your robot. So next, a little vocabulary. These are words you might hear people use when they're talking about programming for FTC. One phrase you might hear is SDK, which stands for Software Development Kit. It is basically a kit of programming tools. It's a set of code written to more easily accomplish a programming task. Another phrase you might hear is IDE, which stands for Integrated Development Environment. This is a piece of software that's used for coding. So when you start typing your code into it, it will highlight different things, different colors to make it easier to read, and it'll complete statements for you so you don't have to remember everything, and it makes it quicker. Also, if you get something wrong, it'll highlight it in red and then offer suggestions to how to fix it. And then it's also compiles your code so you can actually run it. Android Studio is an IDE for coding with Android devices. This is the IDE that we'll be using to code our robot, since our robots are run with Android devices. And FTC App Master is an SDK written by First and Qualcomm made to run FTC robots. So this is a kit of programming tools provided by First and Qualcomm to make it easier for you to program your robot. Some things you should have already done. You should have set up your phones and have them communicating with each other. You should have installed Android Studio and make sure that when you open it there are no errors. You should have downloaded the SDK, which again is FTC App Master. And you should have prepared Android Studio for FTC by installing the correct APIs. If you haven't already done these things, you should probably do them now. Out at firstinspires.org/node/5181, there are a lot of team help and documents. One in particular called Pushbot Build Guide has a lot of useful information and pretty much everything you should have already done. Also, out at GitHub, you can search FTC App Master and you will be able to download the SDK. Now some basics of the phone's apps. So first, pairing the driver station with the robot controller. This basically means that you're telling the two phones that they're supposed to be together, because at a competition there's going to be hundreds of phones floating around everywhere. So these two phones need to know that they need to be connected, not connected to anyone else. I won't get into how to do this, but it is found in the magic document of the Pushbot Build Guide. Okay, so next we're going to make sure you can select an opMode and know what an opMode is. An opMode is code that is designed to allow control over the robot. So this is the code that you will actually write to give your robot certain behaviors. So if you wanted your robot to pick up a cube or shoot a cube or something like that, this is the code that will make your robot do that. So when you open up your driver station phone, it should look something like this. Next you're going to click this arrow and a menu like this will pop up. This is all of the opModes. Currently there shouldn't be anything that you've written in here. A little about Java. Java uses Object-Oriented Programming, abbreviated as OOP. So there are many languages that use Object-Oriented Programming, so Java is just one of the many. A Java object, everything in Java is represented as an object. So if you had a program where there were cats and dogs in a house, a cat would be an object, a dog would be an object, and the house would be an object. And then if you had a game where you had a spaceship that launched missiles at asteroids, then the spaceship would be an object, the missiles would be an object, and the asteroid would be an object. Even the scoreboard that keeps track of how many asteroids you've destroyed would be an object. Objects are reusable. So what this means is that if you had your spaceship and you wanted to fire a missile and then you wanted to fire another missile, then you wouldn't want to have to rewrite missile code So you can just call on the missile code to create a new missile. So then no matter how many missiles you want to fire, then you can just call on that one bit of code and make as many missiles as you want. So this is what makes object-oriented programming so powerful, because other languages that don't use object-oriented programming, you would have to rewrite the code for every missile. Some examples of some FTC custom objects are servos, motors, and any sensors you might have. Again, back to the reusable part. If you had, let's say you can have 8 motors on your robot. You wouldn't want to have to rewrite code for every motor on your robot. So you can just call the DC motor code and create all 8 of your motors from that one DC motor code. Now some object properties. Every object is defined by what it knows and what it does. What it knows are called variables. So let's go back to our cats and dogs in a house example. So our dog object might know its weight, its breed, and its color. But this would vary per dog. So one dog might be brown and weigh 15 pounds and have a breed of a Chihuahua. But another dog might be white, weigh 85 pounds, and have an Alaskan Husky breed. These types of properties are stored in variables. These properties are things that the dog object knows about itself. And then we also have what it does, which are called methods. So let's go over to a cat example. So a cat can eat, it can sleep, and it can meow. But every cat can do these things, so it doesn't vary per object. So within our cat object, you would have methods to eat, you would have a method to sleep, you would have a method to meow. So every cat can eat, sleep, and meow. So variables are things that the object knows about itself, and methods are the things that the object can do, or its behaviors. All objects have these two properties. Classes. Classes are blueprints of how to create objects. So let's go to our house example. Imagine you had a blueprint to create a house. The blueprint itself is not a house, but you can use the blueprint to create a house. If you want to make a house, you just call on that blueprint. So you can call on that blueprint as many times as you want to create as many houses as you want. So a class itself is not an object, but you call on a class to create an object. And then you can create as many objects as you want from that one class. So now I'll show you how to create a new opMode. Remember from earlier that an opMode is a set of code to give your robot certain behaviors to do what you want it to. Let's look at an example opMode that I've made. So here's an opMode I've made. It actually currently won't do anything, but it is a good teaching device. So if we look at this first line, we can see that it is a class named example opMode. So where I have put example opMode, that's where you will put your class name. So you need to name it something that makes sense to whatever opMode you're programming. So if you had the robot that throws cubes, you could name it Cube Thrower opMode, or anything that makes sense to the current opMode you're programming. And then it extends opMode. So what this part means is that this class basically is an opMode. First has written a class named opMode, and our class named example opMode is inheriting all the traits and behaviors from opMode. So if you extend opMode, you have to have 4 inherent methods. You have to have init, start, loop, and stop. So these are 4 methods that our opMode must have, because the robot can initialize, the robot can start, the robot can loop, and the robot can stop. So our first method is called init. So within here you can see 2 curly brackets. What these mean is basically that this is a block of code. So our method has an opening curly bracket and a closing curly bracket. So whenever this method is run, anything between those 2 curly brackets will be run because it's within the block of code that's associated with the method. So this init method is going to happen when you hit the init button on the phone. It's going to happen once and then it's going to be done. So it's going to come in here, and right when you hit init, it's going to go through that It's going to go through all the code in between those two curly brackets and then be done. An example of some things you might put in the init code block is maybe configuring your hardware, or maybe setting up any variables you might need to start, or maybe setting the positions of your servos if they need to start in a specific position. So any setup you might need on your robot. So now we get to the start method. So start is going to be run once when you hit the play button on the phone. Anything within this code block is going to be run once and then be done right when you hit start. So some things you might want to put in the start method are maybe calibrating your sensors, or if you didn't want to have your servos reset and in it, you can put them in start, but you don't actually have to put anything in start. Our team doesn't a lot because it's sometimes not necessary, and you can put anything that you need in it. So now we get to the loop method, and in here is where basically all the meat of your code will go. So this is going to happen once you hit that start button. This is going to happen dozens of times per second. So this is going to happen very fast. It's going to execute this code and then go to the top and execute the code and go to the top and execute the code. So it's happening over and over and over again many times per second. So this is where you'd put in checks for the data from the controller and checking if the buttons are pressed or if the joysticks are pushed forward, and then applying that data to your wheels and to your tools. And so this is where the main controlling of your robot goes. And then this loop method will happen over and over again until you hit the stop button, and then this method called stop will execute once from curly bracket to curly bracket. It will execute the code once. So stop is where you would put any cleanup you might have. We don't really use it that often, but if you need any cleanup, like resetting any servos or turning a light off on your color sensors or anything, then you can put that here. So now I will actually show you how to create the skeleton opMode. So we're going to create the thing I just showed you, and again, it won't actually do anything, but it is a good starting point, and you can save it to copy and paste for later opModes. So when you go within Android Studio, there's a directory on the left side of the screen telling you what folder you're in. You're going to want to go to this directory location. I'll show you how to get there in just a second. So it's been a year since I've made this video series, and there's been some changes to the SDK, and with those changes have come changes in the folder structure and just changes that I thought that you should be aware of, because they really redid it this year. So you might notice the folder structure might look different in the rest of the video. So I've opened up Android Studio, and the first thing we're going to want to do to get to where our opModes will be stored is go into the directory, which should be over to the left unless it's not there, which all you need to do is click this little project tab, and then it'll open up the directory. So to go into a folder, you just click these little arrows, and to get to where we need to go, we're just going to go into team code, we're going to go into Java, and then we're going to go into this little folder, org.firstinspires.ftc.teamcode. So there shouldn't really be anything in here except a little README text document, because you haven't made any opModes yet, and once you've made your opModes, they'll be stored in this folder. And another thing that's good about this directory is that you can go find examples that First has made for you, and those are stored up in this folder instead of the team code folder. So we'll just close that up so it's less cluttered. And then we'll go into the FTC robot controller, Java, org.firstinspires.ftc.robotcontroller, and then external.samples. And then in here, there's a bunch of samples that you can use to just look at and maybe learn some concepts or find some syntax that you didn't know. So if you scroll down to the bottom, right here, you can see an example of the opMode we're about to create. So you can open that up and look at it if you want to see an example of it. But we don't really need to go into the examples right now unless you want to, so we're just going to close that back up and go back into our opModes folder. So we're just going to make a new opMode to experiment with. So we're going to right-click the opModes folder and then do New Java Class. From here it should be just like the old videos, so let's just go back to those. You can name your opMode whatever you want, but since this one's a skeleton opMode, I'm going to name it Skeleton opMode. As a good coding principle, you should capitalize the first letter of every word in the naming of a class. So once we hit OK, it will generate this little bit of code for us. So the only two things on this page that might be different are the creator name and your class name. So the class name that's right here must match this right here, and this right here as well. So the opModes folder that's actually storing your class has to match this. So now we have to type extends opMode. So what this does is, remember, now our class will inherit all the behaviors of opMode. So right now, as you can see, there's an error. So remember that opMode is a class. So if we ever need to use other classes in our opMode, then we need to import them. And the great thing about Android Studio is that it imports them for you. So all we have to do to make it auto import is press Alt Enter, and then it auto generates this line of code. So up here in this area is where all of your imports will go. By the time you're done with your opMode, there will probably be more, like motors and servos and sensors. But again, Android Studio will do that for you, and all you have to do is Alt Enter. So now when we come back down here, we still have an error. So if we click over it, hopefully we can press Alt Enter and it'll tell us the error. So for opMode, if you extend opMode, remember you have to have the 4 methods of init, start, loop, and stop. The only 2 it requires you to have are init and loop. So when we press Alt Enter, we need to implement methods, and then just hit OK, and it'll auto-generate the init and loop methods. So it doesn't auto-generate start and stop because those aren't required, but I'm going to do it anyways. So this first line I'm writing is @override, and all that, what this is that it's overriding one of the methods from the opMode class. There's a method called start in the opMode class, and we're just overriding that method and putting what we want in it. Now I'm writing public void. You don't need to know what that is, but you just need to write it because that's, if you don't write it, then your method won't work. And then start, so that's the method name. And then I'm going to do open curly bracket, and then that auto-generates the close curly bracket, so that if we forget to write the close curly bracket, then our program won't be messed up due to improper brackets. And then I'll press Enter so that there's this box for us to put all of our code. So now anything in here will be executed when we press the Start button. And then I'll do the same thing at the end of the program for stop. So now we have our completed skeleton opMode with the 4 methods in it: start, loop, and stop. Okay, so another thing that changed in the SDK is registering opModes. So now all we have to do is write one little line of code right above the class name, which is right here. So we're just going to do a new line, and then right above we're going to say @teleop, and then we're gonna click enter just to import it easily, or you can just type this line to import it yourself. And then parentheses, name equals, and then quotes. So this is where you're gonna put the name of your opMode. So whatever you put in these quotes is what's gonna show up in the opMode drop-down list on the phone. So I'm just gonna put in skeleton opMode. And then for the next one, we're just going to do a comma, and then we're going to say group equals, and then quotation marks. This is how you can group similar opModes together. So if you had a bunch of teleops connected to a pushbot, you could just say pushbot tele or something. For this one, let's just put teleop. Okay, and since it's an @ you don't need a semicolon. So don't put a semicolon here, or else it'll mess it up. And sometimes, if you copy an opMode, or if you just want to disable an opMode, it'll have this little @disabled thing right here. And that basically just means that it's disabled and won't show up in your opMode list. So to get rid of this, most people just comment it out. And now your opMode will show up on the list of runnable opModes, and you can select it and run it, but it won't actually do anything. So that's all for this video. I build on some of these concepts in the next video, so be sure to check that one out.